Welcome to the course. Let's start on a philosophical note. Why you should test your code? Probably you do test your code anyway by clicking on the pages, entering something in the form and seeing if it's all working. But PHPUnit and in general automated testing help you to do the same thing without launching the browser, without going and clicking. So basically it saves you time. But that's not the only advantage and not the main advantage. The main advantage is to make sure that the system works even if the code changes in the future. Usually, typically, if the project survives for long enough, the team expands, the team changes, frameworks change, or like a lot of things change in the code, and your automated test will still work and will still check if that code is working even after you are gone from the team, even if you hire junior developers who may break stuff. So that makes sense to write PHPUnit tests or any automated tests to have that some coverage, some assurance, and some proof that your code was working at the time. So if someone introduces a bug, then the test suite would probably show it. And these are a few examples of the test coverage I just found on Twitter. So 22 tests, every dot is actually a test. So 22 tests by Steve, and he's happy that test-driven development is easy and it saves him time. Another bigger example, much bigger, is from Mebed, and he has over 1,600 tests, which run for 8 days. So the whole test suite is running in the background somewhere, testing if the whole application works, and only then he would probably launch into production. So these are just a few examples of people making their lives easier for the long run, for the future, by testing their code, by writing automated tests. And now in the actual lessons, we will dive in how to do that. In this lesson, I will show you a very simple example of a very simple test, so you would understand how the whole PHPUnit works in Laravel and how it throws error or returns that the test is successful. So here I have a really fresh new Laravel project without any functionality. It just loads the home page. And let's go to our PHPUnit and let's see what Laravel brings in itself with testing. So there is a folder called tests, and these are all default. I didn't change anything. And there are two folders with example tests, feature and unit. And later in the course I will show you what's the difference. But now let's go to the feature and let's see what it does. So there's a test that does two things. It loads the URL, which is homepage / just home URL, and then assert the status. In other words, it checks the HTTP status of that homepage is 200. And how to run those tests is just you go to the terminal and you run PHPUnit. And that's it. And this is the result. The result is it's called green, so green is a good color in this case. Test passed, 2 tests and 2 assertions. Assertions means those checks. And 2 tests are feature test, this one, and then unit example test. Just assert true. And assert is kind of check, so there are a lot of assertions available. You can assert that that something is on the page, assert some values, and we will show that later in this course. But now let's try to modify something. So we assert that the status is 200. Let's assert that response, assert C. There is a really probably the most common function, the most oftenly used. So assert C and any text on the page, Laravel. So basically we're checking if that Laravel text is present, and if it is, then the test will pass. We'll run PHPUnit again. And then, if you can see, it's still successful, 2 tests, but 3 assertions already, not 2. So it means that our assertion worked. What if we change that and let's try to search for other words? Symfony, for example, another framework. We run PHPUnit, and now it fails. So if we scroll up, the result is dot. Dot is a successful test, and F means failed tests, and we failed. That's the one failure. Result, failed asserting that this text, so this HTML returned, contains Symfony. So that is the error message, and exactly it says which line. So example test, line 19. Line 19 is this one. So this assertion failed. And we can add more assertions. For example, if we assert C, I don't know, cake, PHP, whatever, if we go to frameworks, we'll run PHPUnit and we will have 2 failures probably. So as you can see, test 2, assertions 2, failures 1. Well, it stops on the first. Error. But if we have another test, you can add more tests in the same file. So let's actually try it. Test basic test and then test, I don't know, test cake. For example, we're doing the same thing. So here we will leave that with Symfony, and here we don't need assertions. This one, and let's run it. Again, PHPUnit. And now you can see 2 failures. So 3 tests. 3 tests means 1 and 2, and other one from unit test. And 3 assertions, and 2 of them failed. So 1 failure was fail asserting that Symfonies here contains Symfony, and the second error here failed asserting that it contains cake PHP. So this was a simple example of how it all works, how to run PHPUnit, how to see errors, and how to basically debug it. And I see a lot of people not even starting testing because it seems too complicated. But as you can see here, it's all simple to start. And you can start with really simple tests like going through the pages and see that it's all working with status 200, which means that they are all loading correctly, not throwing any errors. So that is good enough tests already. So I encourage you to start testing, and hopefully within this course we will get into more complicated examples and you will get more and more familiar and comfortable with automated testing. Let's go. In this lesson we will start creating a real project which we will use throughout this course, and we will start write real tests for it, so it would feel for you more realistic, not just assert C Laravel. So this is the thing I've created behind the scenes to save you time. I've run make auth on the project, and the whole project will be the list of products. So product name and price, and we will have example of a real CRUD. It's called create, read, update, and delete functionality. So we will list the products, create the product, edit and delete, and write tests for all of that. So let's begin with the code. What I've created, model product, which is really simple with 2 fields, name and price. Then migration with the same thing, increments, name and price. Then route to product controller, so homepage will lead to product controller index. And controller is a resourceful controller, so with all the methods, but for now we will use only this one. And this is also really simple, so get all the products and view it in index. And index blade file is extending layouts app, which is the same as login form. And let's rename it from dashboard to products. And this is the table of products. For else, it's the same as for each, for those of you who don't know. So for instead of doing if products and do for each, there is a for else command. For else and empty contains the section in case that products are empty. So it's simple, and for now it looks like this. So the homepage, we have empty table with text, no products found, because we don't have a create form, we don't have like anything yet. And let's write the test that if we hit the homepage, we see the text, no products found. We get back to our test folder. It's feature example test. Let's rename the example test file save as. File save as products test. It will be a file with a lot of tests related to products. So we don't need example test anymore at all. So let's delete that. And for the clarity, let's delete example test in unit as well. So we will run only the test that we actually need. We don't need this yet. And let's rename the test basic test to something more readable. So this is an important thing. You have to name the tests for real clarity. So anyone that could read that in the future would be able to read and understand. So test homepage contains empty products table. So we test exactly that. Test that our homepage contains empty product table. That's not a basic test example. Actually, let's remove those for the clarity, for it to be more readable for now. Okay, test homepage, and we do the same thing, hitting the homepage, this get, and we should assert C, no products found. No products found, and assert status like that. And now let's run our PHPUnit. PHPUnit should be one test, two assertions, and all green. And now let's try to add some product. We will do that in the database for now, and let's see how our homepage looks. So test product price 11, created that could be empty, and now our homepage looks like this. So we have a product, and let's see how our PHPUnit works now. Probably will fail, F, because fail to assert that contains no products found. We can also write another test. For example, let's change our PHP store. Test homepage contains non-empty products table. If we do have products, for example, and we can assert don't see. There are a lot of assertions. Actually, I will show you. So if you click response assert in PHP Storm, see how many assertions are there. Assert status, assert redirect, assert cookie, session, JSON, headers, location, assert OK, assert successful views, and a lot of that. And we will show some of them in this course. But for example, in this case, we can assert don't see, no products found, which means that our homepage contains at least one product. Let's run PHPUnit again, and it should be back to green. So the main thing with PHPUnit and with automated testing is come up with scenarios, what exactly to test. Should you test for empty homepage? Should you test for both empty and non-empty? And we will show that in the next lesson. Should you test for product price to be existing on the page? Should you test for some value to be returned on the homepage, calculating that, and a lot of that things. So philosophically speaking, unit testing and automated testing is not about writing the code for tests, but it's coming up with scenarios, what to test, what are the cases, can the product table be empty or non-empty, and stuff like that. In the next lesson, we will continue with our product table, and we'll try to play around with real data. In the previous lesson, I briefly mentioned we can test both scenarios. Product table is empty or not, and this is what we will do in this lesson. So no products found is by default. I've deleted the testing product that we had, and we will have two tests. So first test, we'll test whether the homepage contains empty product table, as we did before, and let's run PHPUnit and let's see if it's still green. So yes, we have one test and two assertions, all fine. And now let's comment out and let's create another test. So test homepage contains non-empty products table, and here we can create product equals product create, and we pass an array, and we just create a product in Eloquent as we did in any project. So it's not about testing, we just use the Eloquent. So product 1, name is product 1, and price would be, for example, $99.99. And then we hit the same URL, we still assert status 200, and then we assert that we don't see no products found, and we also assert that we do see product name. Right. So, okay, it should be fine, and we can launch it. But wait, this is an important thing. If we hit the database with any of our actions in the test, we should make sure that we are not playing with real database, because you can basically corrupt the data, add some testing data which is irrelevant, or delete something accidentally. So first we need to make sure that we are running on testing database, and there are two ways to do that testing. It's pretty common to run tests on separate SQLite database, which is part of Laravel and part of Homestead, which I'm running on. So if you want your test to use SQLite, you go to a file called phpunit.xml, which contains all the configuration for PHPUnit. And this is the most important part. This means that all the variables from your .env file would be overridden by these ones. So app.env is testing, and all of those will be kind of testing settings, and you can add two more, which is db connection would be equals to SQLite, so driver. And also db database would be so-called memory. So this is the syntax memory, which means that the whole database would run in memory and would be deleted afterwards. And db connection comes from a file called config database PHP, which is part of Laravel. And here we have one of the connections is SQLite. So we use this driver, but override the database from SQLite to memory. So let's try to run our test and see what happens. PHPUnit, it should run in SQLite, and it fails. No such table products, and cannot create a product. Why is that? Because we didn't create any tables, we didn't run migrations in SQLite. So we have a trait here in Laravel. We need to use refresh database trait. And this will ensure that in every test, before running the actual test, it will launch artisan migrate. So migrate your database and launch all of that, all of those three user table, password resets table, and products table in whatever database we specified. So we specified SQLite. So at the beginning of this test, it will create tables. Then at the beginning of this test, it will still create a new fresh database. So the results of this test won't remain for another test. So every test will be from fresh state, from fresh database without any data. And now let's try to run it again, PHPUnit. And now it's green. So 2 tests, 5 assertions, and let's see if we have created actually product in the database. And as you can see, our products table is still empty. I've refreshed it, so which means that it did succeed in SQLite in memory. Also, we can use another separate MySQL database instead of SQLite. So the main reason of that, if your project uses any SQL queries related to MySQL and relying on MySQL, specifically on syntax, if you use like date formatting from MySQL, like string functions, date difference for functions in any like DB raw statements, then you should use MySQL. And I can create a separate database. Let's test it. So we add a database. I will call it Q2_testing. Let's change the Unicode. Okay, we have a fresh database, and we go to our phpunit.xml and we change that to driver MySQL, and database should be Q2.testing. Okay, and let's run PHPUnit again. It should be still green. And then, so as you can see, migrations run successfully, and we do have that testing database, which would be refreshed every time we run PHPUnit. Another way of configuring that thing outside of PHPUnit, you can create a separate .env file for testing, which is called .env.testing. So if we go to our .env and we do save as .env.testing, this, and then we can override whatever values we have here. So DB connection would be the same, database would be Q2 testing, and then we can remove these lines from PHPUnit. So this will be empty, and it will take all the env files from here, but PHPUnit variables are more important. So it will override, this is like the main data, and anything would be overridden with env testing. And let's try it again. PHPUnit, it should be green, and again the database should be created. Right, migrations, products table, which is empty. At the end of the test, it was empty. Right, so this is the way how we deal with the data assertions. So every test in theory should contain 3 phases. One phase is doing something with the data, like setup phase, set up the situation. So for example, we create a product, we create a set of products, we insert something, anything. Then we do the action, so go to homepage, and then we assert what should happen or what should not happen. So these are 3 phases. If we can kind of separate that visually. So this is phase 1, this is phase 2, and this is phase 3 of every test. In later tests, we will get more complicated examples with more data and more assertions. In the last lesson, we've created a test that asserts that product name is present and no products found is not found, so not seen on the page. And in this lesson, I want to explain you a thing called false positive. So some of you may wonder why I wrote product name here instead of just repeating product 1. So for example, we create product 1 with price, and we probably could repeat that product 1 here. But what if we do something like this? For example, we create product 1000, for example, or 10,000, and this, what do you think? Whether it will assert C true or false? Let's try it out. Let's go to our PHP unit, run PHP unit, and see tests are successful, but in fact there's product 10,000 on the home page, not product 1. So with this video, I want you to be careful with false positives and test exactly what you want to test. And more logical way of testing is to test the data, not the visual thing. Assert C and assert don't see is good for simple tests, for simple texts, like no products found. But for data, it's probably better to test the actual data. And here I want to show you one trick. So I will comment out one thing. If you do a response, so this get, within response there is a function called view data, and view data you can specify a key called products, and we will dd and I'll show you what it does. So by the way, when testing you can use dd, die and dump, in whatever place just to debug the test. So in our controller, this is the index method of our controller, we have products and we specify the products, pass that to the view. So this is exactly the way how you get view data, and you specify the same key. So if we dd products, let's go. Oh, of course it should be view products. Right, and here's the example. The data is eloquent collection, so this is exactly what we're getting here. Here we get eloquent collection of products, and this is exactly what we get here. So now if we do have that data, we can assert something else. Assert not C, but assert exactly what we have here. So in this case, view products, it's a collection. We're doing the first result, and we get the name here. So instead of assert C product 1, we assert exactly the name of exactly the first entry of the view data. Let's run the PHP unit again, and it should be passing. So in this short video, I wanted to show you how to test the view data instead of doing assert C, because it is more accurate and prevent false positives. In this lesson, we're going to talk about unit tests, and unit tests versus feature tests. What is the difference and how to generate unit tests. Up until now in this course, we covered only so-called feature tests that test the features. So we make a request, we get a response from that web page or URL or JSON API, something, and then we assert that is correct or not correct. Unit tests test the logic of the application, so nothing visible, no endpoints usually, and they test internal logic of some data processing, some service, some logic, piece of logic, some class. Basically, usually unit tests is putting the data into some black box, some service somewhere, and then getting something back and testing that everything is all right, like calculating the price with formula, testing difficult logic like unique calculations or something like that, or filtering the data. And let's have an example here. So we have the same product table, but with one additional new column, price in euros. So let's imagine this is the price in dollars and this is the price in euros, and we don't want to store it in the database because it may change or for various other reasons. And we will make a service that will calculate price in euros from price in dollars. And actually I've done exactly that. This is the logic. I've implemented that column, price in euros, and this will be product price underscore EUR, but it's not the column in the database. It is, if we go to product model, It is so-called accessor. So we have a calculated price field. So price euro, it's in camel case, which is transformed to snake case. And for this, we have a service, currency service, also a new thing I've created under the hood. And it's a pretty fake example. In real life, there's no constants for rates, but just as an example, we will be calculating conversion from the amount of money and from currency to some currency. And we will get all the rates, for example, here. In reality, we will be getting them from somewhere every time from some API. But let's imagine that we have an array of arrays, so dollars, and then there will be more currencies. Like, for example, GBP would be like, I don't know, something like that, and more currencies. So in this example, let's leave it like that, and this is the function. At first, rate is 0. If we do find the rates that we're interested in, then we calculate that. Otherwise, it's still 0, and then we multiply just amount, initial amount, rate, and precision is 2 decimal numbers. And this is pretty simple, and it actually works. So this is the result. 89 euros is price of $100. And that kind of works because the real database, this is the real database, so the product is with price 100, so there's no field price euros. So it all works, but now let's try to test it. Let's write a test for the currency service, whether it works correctly, and for all the cases that may go wrong, which is really important. And we can generate a test. We can actually generate a test from artisan, from terminal, and we go artisan, make test, and let's call it currency test. And there is one important flag. If we don't provide it, then it will be created in feature folder, but if we do provide it unit, it will be created, that file, in unit folder. So tests unit. As you can see, it appeared here, currency test. And it provides a simple example test, which we don't really need. So we delete that and call public function test convert dollars to euros, like that. Let's put amount in USD equals 100, and this assert. What we can assert here, basically we will call that service and we will assert that the result is as we expected. So if we assert equals, if we expect that to be 89 euros, again, it's a pretty fake example, so in real life it will be calculated differently, but for simplicity, let's stick with me. So 89 euros is expected from $100, and the actual call of that would be new currency service, like that. Then we give it this one, and then new currency service, convert. PHP Storm helps me here, so amount in dollars, and then currency is from USD to euro. And that's it. We don't need database here, so we don't need refresh database or anything like that. Because that is happening not in the database, and that's another point of unit tests. Unit usually are dealing with internal data with some variables that are transformed into other variables without even touching the database usually, but that depends. Now let's go to our PHP unit and let's see if it succeeds. Yep, it's correct. So we had 2 tests and 5 assertions, if you remember. Now we have 3 tests and 6 assertions. So this one passes. Let's add another test, and let's convert, for example, GBP, which we don't have yet, and that is actually the point. So we should create a test that actually fails. Amount in GBP, and we would expect probably 0, because, well, the result of 0, so any amount rate would be 0. If it doesn't exist, the amount would be 0 expected. PHP unit F, now I see F, test convert GBP to euro, fail asserting that 89, expected 0. So as you can see, I didn't change those, so that's why it failed. So amount in GBP, I've named the variable differently, but that should be the actual correct call. And this is how you work with PHP unit actually. Now it succeeds, 4 tests, and this is how it works. You write a test, then that test may be incorrect as well, so you have to fix the test. You have to fix the code, and actually sometimes even both. So you go back and forth until it actually is green and the code is correct. And if we do, for example, some fictional example of, I don't know, Australian dollar, and it doesn't exist, and we expect that to be, I don't know, 99, and amount in AUD and amount in AUD, go PHPUnit, it probably will fail because it is not as expected. And also one more thing, the code itself may not cover that scenario. So for example, if we go and comment out this one, so we're always calculating the rates, and for example, we don't even think about the situation that the array item may not exist. So if we go here, it's not, now it's failing because the failed assert, and now it will fail because the code will fail. The code will fail asserting that's 0. Oh, yeah, okay, so I wanted to show you this example. So for example, we don't do any checks, and we are trying to access the array example, and it will fail. It's not even F, it's an E now. It's not F, because F is a failure of test, and E is an error. Error meaning in PHP. So the error of currency test or undefined index for both GBP and AUD. So that is a difference between F and E. F is a failure of test, E is an error in the application. So let's return it back to normal and back to green, and let's remove the test that is probably actually, oh, there's another. So probably we should test also whether it's in dollars, but in some other currency that doesn't exist to convert to. So same USD, and we convert USD to GBP, which doesn't exist. We don't have that rate. Amount in USD, and we should expect 0. And now let's see if it actually is green. Yes, it is green. We have 5 tests and 8 assertions. Final thing I want to mention here, look at how important is the name of the variables here. So in your test, make it as clear as possible to read. So for example, if we do amount, just amount, it seems like a normal variable name, but it's not crystal clear what is the amount of. What is it money, is it what currency, what dollars or euros. So in test specifically, well, in all of the code you write, but in test specifically, try to be as specific as possible with variable names, function names. It is really important. In this lesson, we're going to be talking about creating bigger amount of data for testing. So for example, in our case, we have a list of products, but what if we want you to test the pagination? So for example, we want to seed multiple, like, I don't know, 10 or 20 or 30 products, and then test if the pagination works correctly. So one way of doing that, I actually have created the code behind the scenes. One way of doing that, so this is our test. Test that paginated products table doesn't show 11th record. So imagine we have a pagination by 10, and we create 11 products, and we see that the last product isn't in the table, so assert don't see. And the code for that, it's controller, instead of all, we're doing paginate 10, and the blade doesn't change much except for this one, so links to other pages. And that is okay, but there's more elegant way to do this one. So instead of doing for each or for or creating a lot of products, there's a thing called factory. With Laravel, we have a folder called database factories, and by default, it's one user factory. What do we find here? It's a class that defines some fake data for a certain class. So in this case, for user class, we have fake name, fake email, and some random password and random token. And it uses a library called faker under the hood. It fakes a lot of data, so you can fake the name, fake the email, fake a lot of stuff. So similar to that, we can create our product factory. So let's do that. We go file save as for this. Instead of user factory in the same folder, we create a product factory. And later I will show you how to actually call that. Product factory. And instead of user, we do product class. Probably it will be better to use it here. I prefer to use uses up front and at the top instead of just using full path in the code. So that, what do we need for product? Name could be a name, and price, let it be faker, and now PHP Storm will show you random float. Random float is good enough for me. Random float, 2 decimal numbers, minimum price from 10, maximum 99. Okay, and we don't need anything else. So now we have a faker for product. This one is irrelevant now. And how do we call the factory? So instead of doing for, we do factory, product class as a parameter, product class name, amount of the values that we want to store, and then call create. And that's it. Instead of this one, we will comment it out, and the result is products. And the result is actually collection. So instead of assert C product, now we can do products last name. And actually, before doing that, I will show you that it actually works. So product name, uncomment this one, uncomment this one, and let's go to our PHPUnit, and we run PHPUnit, and let's see if it's all green. Yeah, our previous tests and this one is green, so it means we create 11 products and we don't see a product name. Actually, let's try to do 10 products, and it probably will fail. So I will prove it to you that the test actually is doing what it has. Fail to assert that does not contain product 10. And product 10, as you can see, it is in the table. But if we create 11, the last one isn't in the table, which is correct behavior. And now let's replace this one with this one, and products last name, and we run PHPUnit. It should be green. Let's hope for that. Yep, it is green. So under the hood, it's creating 11 products. It's getting the URL and assert that it doesn't see product last name. Of course, to be more precise, we should do that as in last example with view data instead of assert don't see. But purpose of this lesson was to show you how factories work. Inside of factory, you can define a lot of fields, a lot of like faker has a lot of properties. Let's run through them. So test, first name, last name, country, phone number, company name, URL, address, city, country code, credit card, a lot of things. So you can see the scroll down here. The library is called Faker, so you can Google it up and see how much more it offers. But in general, you can fake a lot of data, or you can do your own logic here. So not use Faker, for example, but use factory is a pretty good practice in testing. Final thing I want to show you here with factories is that you can override the factory properties by whatever you want. So in the default factory, we have faker name and random float for the price. But what if we want to change the price to be $9.99 for all the products? You can pass an additional parameter to create a function, and with array you can override any of the fields. And if we run that test, it will still be green, but we won't see the result because it's happening under the hood in the temporary database. So let's do info products. Info will write the whole variable into log, into Laravel log, which is empty currently. I've emptied it out, so let's run the test and let's see what the price actually is. Is it random or not? The test should be green. Yep, it is green, and let's open our log. And this is what we have. So some name, random name, price $9.99, product number 2, price $9.99, you can see here. Same for the other one. So this is a proof that it actually works. So price $9.99 as well. So it's not random. So this way you can override some data. So for the factory, that's the overall logic of the testing. So factories are for main data which wouldn't really change much, but for every test you can override for specific case that you want to test in that particular test. In this lesson we're going to talk about authentication and how to test that authenticated user access some of the data and not authenticated user don't have access. And for that we will kind of scaffold a test, a new test. So we go to our terminal and we run, let's clear it up, PHP artisan make test auth test. And we will test a few features of our app. So auth test, it's empty, it's scaffolded basically, but we need to use refresh database, right? And then let's write one test. So public function test login redirects successfully. So that would be test number one. We will try to log in. So create a user, post to login, and assert redirect 302 to home. That's how Laravel works after login. It redirects 302 to home URL. Next test we will write, it would be function test authenticated user can access products table, probably products table. So that would be positive test, and then there will be negative test. So test unauthenticated user cannot access product table. So we'll do same thing, create a user, post to login, so login, then go to homepage where we have products, and then assert status is 200 and everything is good. And then in this case, for unauthenticated, we won't create any user and we won't log in. We just go a homepage and we see assert status is not 200. Okay, let's begin with our first test and let's try to create a user. And for that, we will use a factory from the previous lesson. User class create. Oh, no, that user class create. That's the syntax. We need only one user. So in previous lessons, we had another parameter of like 11 or 10 products. If we don't need multiple things, we just create. And then we post to login. So this post URL would be login, and parameters for post data would be array, and we need to pass email and password, right? Email would be something and password will be something. So what would be the logic here? Password would be something, and we can code the email and password here. So email would be our admin.com, for example, and password would be bcrypt. That's how the password encryption works in Laravel. Bcrypt would be password 123, for example. And we pass the same data for login, admin, then password is password 123. We post to login and we assert. So this is our data phase, this is our action phase, and this is assertion phase. So this assert redirect, there is a function. So in this lesson you will learn quite a lot of new things. Response should be the result. Response this, and then we assert on response. Response assert redirect to home, and that's it. Probably assert status is also important. So status should be 302, which is redirect actually. 302, I think it's this one, and this. And let's try to launch it. We will comment these out at first, and let's try to run our whole PHP unit. And it is successful. If you remember from last lesson, it was 6 tests, now it is 7 tests. And to prove you that it's actually working, let's change that password 12 to password 123, and it will then probably fail because admin and password won't match. So if you see one failure, actually expected home, and it's actually redirecting to the test because it's redirecting back to login form. So this is test number 1. It is completed successfully. Test number 2, can authenticated user access product table. And for that we will change the behavior. So we will create the same user. Actually, let's copy everything here. So we create admin user, we log in, but we don't need to assert the redirect because it's already tested by another test. Actually, we don't even need this one, and we don't even need to log in, because there is one trick. If you want to log in with some user and test something, there is a function called this acting as, and you pass a user, and then you can do whatever, get something. So we need user from here, so we need a fake user. Acting as user, we will get to the home page, so we don't need to log in anymore. We go to home page and assert the status is actually 200. No, the response. So the result is response, and response assert status. No, not this, response assert status. Assert status 200. So if I'm not authorized, then the status would be different. 302, I think, was redirected to login form. And for now, we didn't do anything to actually restrict the home page, because currently our homepage product controller is accessible publicly, and we need to change that. Middleware auth. Middleware auth means that only authenticated users will be accessing the page. If we go to our homepage and refresh that without being logging in, we should be redirected to login form, as you can see, right? So now let's launch our test suite and let's see what happens. Let's see what happens, and I'll show you another interesting thing. So by doing that, we have two failures in the same product test. No, it's actually in a different file. So by doing this, we actually broke previous tests that were actually working. And this is a typical thing I wanted to show you in a test. So by writing more tests and writing more behavior and introducing new logic, you may break the old tests, and that is completely normal. So by using middleware, by introducing middleware, we are screwing the products test, because now it's asserting the status of 200, which isn't the case. So we need to change the tests. That's the whole thing. We need to go back to the tests, and we need to fix the old tests, and assert 200 will fail because the status is not 200. You cannot access homepage without login. So we need to actually create a user for all of the tests here. Actually, we need to rename example test to product test. So we need factories here, user class, acting as user. We need to add acting as everywhere here, acting as, and then here as well, acting as user, and test pagination also should come with user. Now let's see what PHPUnit shows us now. Look, it's green. So that is the thing I wanted to show you, is sometimes you need to get back to your old tests and see if it fails and fix something. And this test is also passing. Our new test authenticated user can access product table. And now let's write another one, negative test. So we will, without any user, we will go to our home page and assert that the status is not 200, which is actually 302. It should be a user. We don't use any acting as in this case. We just hit the home page and we assert that the status is 302, and redirect, actually assert redirect to login. Assert redirect to login. And let's run our test. Is it green? Fingers crossed. It is green. So 9 tests and 16 assertions. And within this lesson, I will recap. We've tested the authenticated part. So you've learned what is acting as means, how to redirect, so assert redirect, how to post to login form with the data of array, and also you've learned how to get back to your previous tests and make them work again. In the last lesson, if you remember, we've made the product table under middleware auth, which means that only authenticated users would be able to access that. And within our test, we've added a new user in every method. So for every request, we're acting as a user. And if you can see, this part is repetitive. So let's clear it up. So with every test, we create a user, which means a repetitive code with pretty much the same parameters and everything. So how can we do that? How can we clear it up so we won't have to create a new user in every method? And that applies not only to the test, but to any code you write. From time to time, if you see some repetitive code, if you see a pattern, you should refactor it and extract it to a separate function. So I will show you two ways here to make it more like cleaner code. At first, we will try to create a private method. So private method, private function create user, for example. We will just copy and paste that. Instead of just user, we will return it. So return the user, return factory, and here we will have user equals this create user, and that's it. It's already cleaner because it's one line of code in every function instead of doing this every time. So instead of 5 lines, we'll have 1 line. So this create user, and here this create user. And that is better already. So let's try to launch our test case and let's see if it's still green. PHPUnit. Okay, all green, 9 tests, 16 assertions, 4 seconds already. So at some point we will probably need to optimize that for speed. But anyway, it works, so we're returning the created user. But even better way is to use a function called setup in PHPUnit in test cases. It's kind of a constructor for test classes, so you can create public function setup, and PHPStorm will help me with that. I just click enter, and don't forget to call parent setup because it comes from the parent from the main test case and runs a lot of things behind the scenes. And then after that, after parent setup, you can do whatever you want. So you can copy that from the private function to this. And the problem here, there's nothing to return to. So if we return, the setup result should be void under the object-oriented programming. The signature of that function is to return void, so we cannot return anything. But we can assign it to a private variable property. So let's add a private user, and then we will return that factory result to this user equals, and then we can skip creating user in every method, instead use this user everywhere. So this user, delete that and acting as this user, and in the third method we also add this user. Let's delete that to do. It was auto-generated by PHPStorm. And yeah, let's try to refresh that again. Run PHPUnit, and let's see if it's still green. Yep, it's still green, a little faster, 4 seconds now. So yeah, these are two ways to clean up repetitive code. So if at the beginning of each test you are creating something, you can create a private method for that, or if it's applicable to all the functions within that test, within that file, it's probably better to use setup and assign any private logic to private variables, private properties, and reuse that within the tests. Let's move on with our lessons and try to add a new product to our table. So this will be a button for add new product, and here we will introduce a few roles to our user. So there will be admin user that can create products, and there will be a simple user that cannot create product and shouldn't even see that button. And we will write test for both of those cases. So behind the scenes, what I've done here, I've added a field to users table called isAdmin. By default it is false, and then I have added that to user model as fillable field. Then I added a middleware called isAdmin, So app HTTP middleware is admin, and if it's not admin, the app will abort with 403, which is forbidden. And then I've added that middleware to app HTTP kernel file here, so it would be registered. And then in our routes, I've made a little refactoring to get to products as almost resourceful controller. So homepage will redirect to product, and products index method will be middleware only by auth. And everything else, which is like creating, managing products, deleting, and all that stuff, will be also middleware by middleware is admin, and with names of the routes. Probably final thing I want to show you is index page here. So this button is also, well, it's under middleware but with different syntax. So if it's admin, then we show that button, otherwise we don't. And we already have that page set up, so if I click add new product, there should be a form, which is simple 2 fields. We won't store it here for now. We will work only on the create form and testing whether it's visible or not to admin and simple user. Now, I've written a few tests already behind the scenes to save you time, and I will comment every line here. So there are 2 tests to test if the create button is visible or not. So it should be visible for admin and should not be visible for non-admin. And here, as you can see, I use a factory. We will get back to that. In factory, I override one field is admin equals 1. And then I'm acting as that user. I get to products and I see if there is a button add new product, right? On the other hand, I'm using non-admin, so creating just a simple user without overriding is admin, as you can see the difference. And then I assert that we don't see add new product. And that succeeds. Actually, let's comment out everything else for now, and let's launch PHPUnit to prove you that it actually works. Yep, so the state is green, 11 tests, 20 assertions, so this is working. So with admin, I do see product button, and with non-admin, I don't. And this is the philosophy behind that, so you have to test all of the cases and backend and front end as well. So you can test the buttons with different tools, but in general, you should both test that the visible things are visible and then in the logic. So in the logic, I have 2 more tests to assert the status of the request if I do know that URL. So it's not only about button. Someone may have guessed that the URL is product/create. So if I go to that URL directly, also I should be able to access that with status 200 if I'm an admin. And if I'm not an admin as a simple user, I should be accessing with status 403, which is forbidden. So these tests are also written, and let's launch PHPUnit and see if it's green. PHPUnit, there should be 13 tests now and 20 something assertions. Okay, we're okay, 13 tests and 22 assertions, so it's all working. Final thing I want to get here is get back to the factory thing. In the last lesson, we've refactored the user creation phase to a setup method, this user with factory. But that doesn't really suit us because sometimes we need to create an admin and sometimes we need to create a simple user. So for that, we will create a separate function here, private function create user, and the parameter is admin equals false by default. And then we will copy that here. So setup will be deleted because we don't need to set up anything anymore. So create user, unused private method, we will use that. Is admin equals is admin, and then we will probably change this, so is admin, then email will be admin, else will be user at user.com. Right, create user, and then this create user. We don't need to return anything because it is saved in the private property. So this create user, also this create user here, here, or actually within a button. So is admin here, so should be create user 1 is admin, and then change it to this user. So probably it will be like this. Is admin should be 0. Product create page, so that is a little different URL. Products create and is admin should be 1 in this case. And same for the last test. Without factory, create user admin 0 and see if it's 403. I think we've covered all the cases, and now let's try to launch PHPUnit again and see if it's still green. Yep, it is green. It's still within 5 seconds, so kind of measurable. And yeah, so within this lesson I wanted to show you how to test a few things which are visible and non-visible as well. Also touch on refactoring the factory thing into a private method and dealing somewhat with roles. In this lesson we're going to store new products and test that it actually works. So if we click add new product, the name would be test, the price would be something, some number, and it all works. The main controller behind it is pretty simple. So standard product create and redirect back. So nothing fancy here, no validation, nothing. And how can we test that it all works properly? First, of course, we need to post the form. No, actually first we need to create a user. When we have a private function for that. Remember, we created it in a previous lesson. So we create admin user, and then we go to post to products with some data. Products is covered by the route, this one. So post to products and method store. So if we post to products with name new product and price equals something, we should be able to assert, actually it should be a response. So we assert the response is redirected back. So assert redirect to URL products. And this would mean that this part happened successfully. For now we didn't test this one, but we'll get there. First let's try to launch this PHPUnit and let's see if it's green. And it's not green because we forgot one thing, acting as. And this is the part where test actually comes useful, because you keep missing small things, and test would technically, in theory, prevent that, or at least show you the errors. Now let's launch PHPUnit. Okay, it's all green, so we are redirected back with products. Now, how do we test that the product actually was created successfully? First thing is we can test assert database has, and see the parameters table and data. So we can assert that the database products table has product and price equals 99.99. Okay, let's run PHPUnit now. Okay, we're green, and to prove that it's actually working, so let's change that to 99.98, and then it will probably fail. Yep, we have an F because failed to assert 99.98 found in the database. Right, so that's assertion for the database, so you can assert any table name for any new data. And then let's actually test that it's the last record that has been created. So let's get the product. So product order by ID descending first. And then we assert with this, assert equals new product name and then 99.98 $1.99. I think it's without those apostrophes, so price, 2 assertions more. Let's launch PHPUnit again. All green. So this is an example test of how you can test the data that comes to the database, then assert that database has the data, and assert that actually the last record was created successfully. In this lesson, we're going to try to edit the record and see if the form is loaded successfully. So if we click the edit, the form should appear with 2 fields, name and price, and the code for that is pretty straightforward. So product controller, edit, route model binding, edit form, and variable product. Also almost copy-pasted code from create form with just different method put, a different route products update. So nothing really fancy here. In the web, it's just route put. Similar to resource controller, it would be route resource. We just divided that to different middlewares. That's why it's separated. So product update, nothing really, as I say, fancy here. So just edit form with update. And now let's write a test that those values are actually correct. So test and 100. And how do we do that? First, of course, let's create a user. So this, create a user, admin1. And then we will go to that user, response, this acting as this user. We get to that URL of products, something edit. How do we get the product ID here? So we have to create a product. So it would be product ID. And product will be created with a factory. So product equals factory, product class, create. And we have that factory, if you remember here, products factory, this fake name, and fake price. Okay, so we have a factory, we have a product here, and we have a response. And what do we actually assert? That's an interesting thing. Of course, we, as usual, assert that status is 200. But also we would need to assert C, and there are actually various ways to do that, but I prefer to check the HTML code of that value. So for example, value would be equals to product name. And also we assert C, value equals product price. So inside of the HTML code, so if we go to the source here, value equals this one. So value test and value 100 would be exactly the values that we'll be looking for. And if we find both of them, probably it's not guaranteeing 100%, but it's most probably that is in different fields, in different inputs, and with correct values. Let's try to launch that. We go to PHPUnit. Let's clear it up. PHPUnit, and we failed. We received 404 because it's products, not product. Okay, again. Good. And we have 15 tests already with 30 assertions, and we're moving on through the CRUD while creating the product, editing the product, and next lesson will be for updating the product. In this lesson, we're going to process the edit form and update the product and see if it's all successful. And not actually successful, in this lesson I want to tackle the validation errors. So imagine that we introduce a validation rule that name should be at least 6 characters. And what if the validation fails? We need to test that if the user enters wrong product name, that the validation actually is triggered. And let's write a test for that. First, how it works, update the product. That's pretty simple. And for that, I've created update product request, separate request file in app HTTP requests folder. And the rules for the validation are these. So required name and price for both, and minimum 6 characters for the name. And let's see if the validation fails. And actually, let's try it visually first. So we edit the product. Let's refresh that again. Let's leave that as test. and the validation should trigger. Yep, name must be at least 6 characters. So what happens? We are redirected back to the form, so we need to assert the redirection back with session message. What is the syntax? Let's take a look. So first, in our product test, as usually, we create a user, then we create a product, and then we need to post to that product. Now let's launch a request, so response will be equal to this put, not to get or post, because it's put for the update. The URL would be products/product ID, and the parameters would be name, the invalid name of test, which is shorter than 6 characters, and then price would be normal 99.99. Also, we need to add acting as here, acting as this user. And now what do we assert? First, we assert that we are redirected. Assert status is 302. We get redirected back to the edit form. And then a new thing for you, we need to assert that these two parameters, only one of them comes with redirection error, with validation error. So response assert session has errors, and the parameter is array of possible keys. So we need to assert that name comes with validation error, but price isn't included in the validation. Now let's run PHPUnit. And now we see it's all green. And to prove that it's actually working, if we add a price here, remember price isn't validated. It is validated, but it will pass validation because the only rule for the price is that it's required. And we do pass that. That's why probably it will fail. The test will fail, which is exactly what we wanted. Session missing error price, which means that we tested that only name comes back and not the price. Another thing I want to show you with validation is validating JSON errors or API requests which return JSON. So let's copy that here. In JSON requests and API requests, we don't we don't have status or redirects or sessions or anything like that. So we test for product, JSON, correct validation error. This stays the same, this stays the same, and with this I want to show you another trick. So there is one parameter extra. So we put the request URL, then parameter, and then third parameter, optional parameter, is actually the headers. So for headers we need to do accept application/JSON. It would tell that the request accepts the application JSON, and then Laravel will send status not 302 but 422, and I guess that's enough. And let's launch PHPUnit. Yep, we're all green. So this is the case where you want to test the API response. You just put accept application JSON as the third parameter of your request, and then the status will be 422 as Laravel validation defaults. In this lesson we're going to work on the final part of our CRUD, is deleting the product. So I've made a button, delete. It works like a typical resource CRUD, and we will write a test for it. So in index blade I've added this, so form for deleting with all the on submit return with hidden tokens method and all of that, and in product controller it's just simple destroy method to delete and redirect back, and in the routes we have this route delete. So again, nothing too fancy here, and let's test if it actually works first. So let's add a product, some product with a price, and then we will delete it and we'll see if it actually works. So delete, okay, and it's gone. And now how do we write a test for it? We have a simple test delete product no longer exists in a database. So what do we need for that? For seeding phase, for data phase, we create a user and we create a product, right? Then let's assert equals that the database contains one record. So product count. And this will be the first assertion without even touching the database, without touching the form. And then we do response equals request. So this acting as this user, we do delete request. So we did already get requests, post requests, put requests, and then it's time for delete to products / product ID. And what do we assert then? So we assert redirect 302. No, assert status 302, I think. That we are redirected back to the form, back to the table, and then we also assert the same thing from the database, but with different expected results. So now we expect 0. So this is the difference. We have one assertion here, one product at this time, and after we make a delete request, we assert that the product is actually gone. And let's run PHPUnit and let's see what we have there. Okay, PHPUnit is successful. We have 18 tests by now. Now let's try to fail the test, so we would be sure that it actually does fail with wrong data, and it does fail. Failed, asserting that 0 matches expected 1. So this is a typical way how to test deleting phase in the CRUD. In this lesson, I want to show you how to test file uploads in Laravel. So imagine we have a form for a new product and one of the fields is photo field. How to test that it was actually uploaded correctly. And first, this is our code. The code in create blade is pretty simple. First, of course, you need to add this to the form and type multipart form data, and then that's the field. Input type file, nothing really fancy here. In the controller, this is the logic. So if the request has file, of course, we're creating the product without photo, and then if it has a file, then we get to the final and store the file in logos folder. And the settings for that is in our file systems. So config file systems PHP. So default disk is local because I didn't change anything in .env file. And that is all working. Actually, we need to also add a photo field, and there was also a migration for products. So string, column name, photo. Let's try if it actually works. So demo price and photo is, for example, any random file. Save product. It is saved, and let's go to the folder and let's see where it's actually stored. Storage app logos in here. So it is actually stored and it is working. Now, how do we write a test for that? There are a few things that you need to know in Laravel. In Laravel testing, you can actually fake the storage by calling storage fake. And the parameter of that fake is what disk to fake. In our case, it is local disk. And before that, of course, to make a request, we need to create our admin, create a user, which is a private function here, and we provide a parameter 1, so create admin user. Then we fake the storage, and then we need to make a request, so this post to the products URL, and with some parameters, right? And of course, we need to add acting as our user, so this user. Right, our parameters would be name is product with photo, price would be whatever, 1, 2, 3. And now photo, what should be the photo? And that's another new thing you need to know. There's a thing called uploaded file. Uploaded file, I think it's this one. And we need to do fake and then provide an image. So we need to, there is a function that creates a temporary image for you with whatever file name you want. In our case, that would be logo JPG. JPEG file. And what do we assert? And that's the third new thing you want to take a look at. Storage, disk, local, assert exists. That's the syntax. So assert exists. This. So it exists, logos, logo, JPEG. Now I will explain. So we are using the storage disk local, the same as we're faking, so it will be fake, and I will show you later what is exactly where it's stored. And then we assert that the file exists, in logos folder specifically with the same name logo JPEG. Logos comes from the controller because we're storing it in logos folder. Now let's run our PHP unit and let's see if it actually exists. PHP unit. All green, 19 tests. Now, where is the file actually stored? If we go to the same storage, framework, testing. This is testing, disks, local, logos. And this is the logo, which is actually a fake image. So this one, just a random image, random dot. So that is all working. We're actually storing the file, but that storage fake local works in a way that it provides a temporary testing folder, actually stores the file, actually fakes everything, and then asserts that the file actually exists. So this is a simple way how to test uploading files and generally file existing in Laravel and with PHPUnit. In this lesson, I want to show you a few tricks how to run PHPUnit more elegantly with a few flags, how to filter the test that you actually want to run. So if we run PHPUnit, as we did throughout all this course, we should have around 20 tests altogether, 19 tests and 38 assertions. But we can filter what tests actually would we like to run. So I remind you, we have feature tests for auth and products, and we have unit for currency. What if we want to run only products test? Sweet, so PHPUnit minus filter product. And it will run only product tests, or actually everything that he will find in a product. So we have 15 tests for product, and if we do auth, for example, filter auth, it will run only auth tests. It should run only 3 tests. So this is how you can filter. Another way to filter is to create specific groups for tests, not only by files, but within the same file or within all the test suite. You can add a dog block comment group. So the main example for us, for our team, it was to have approved tests, which are kind of approved by management or by CTO, and they should be green, they should be working. Meanwhile, other tests may fail. They are not in production yet, they are not ready yet, not really tested. So we can specify, for example, group approved, named a group, and we, for example, specify the group only for 2 tests. And then we can run only those tests with PHPUnit minus group approved. And it should run only 2 tests now. Yep, see? But also we can exclude that group. That's the contrary. So we can do minus exclude group. I think that's the syntax. And now it will run all the tests except for the approved. So 17, the total is 19, so 17 are not approved. So these are 2 ways to filter what tests you want to run. And final third tip I want to show you is how to prevent multiple errors to appear. So for example, in those 2 fields, let's make both test failures. So for example, we add this and we assert logo 3, which fail. So both tests will fail, and if we run PHPUnit now, actually for the same approved group, we should see 2 Fs, probably 2 failures, F and F. So 2 failures, 1 and 2. And there is a flag that allows you to stop on the first failure. So you can do stop on failure. And it will show only the first error, so you wouldn't need to take care about everything else. You would be focused only on that failure. Otherwise, if you have multiple failures, there will be like long text, hard to search, that you would have to scroll up and down. But stop on failure shows you only the first failure and ignores everything else. So these are 3 tips, 3 filters that I use myself quite a lot and probably will be useful to you. In this lesson, I want to show you a concept called test-driven development. So before this lesson in this course, we were creating tests in the following structure. So we create a feature, I do the code, and then we write a test for that to test if it actually works. But another approach from like a philosophical point of view is to first write tests and then write the features for it. It's actually, it may take longer, you would think, but then how it helps, while writing tests, you think about the feature deeper, you think about all the cases, all the potential data that would appear, and then you think about the feature before even building the feature, and then avoid some errors. So it takes longer, but it may pay off. So let's create one more feature in our product list and do that with test-driven development. And I've come up with an idea to add product to the cart, like in a typical eShop or somewhere online. So in addition to edit and delete, there will be a button add to cart. And then after adding to the cart, somewhere here on the top, there will be a link cart with showing how many items there are in the cart. We won't implement the checkout, the money, the purchase part, but adding to the cart, we can do that. It's pretty simple, relatively. So let's start by writing new tests, not by doing the feature, not by coding, but writing new tests. We go to our terminal, and we go, let's clear it up, PHP, artisan, make test, cart, test, and that's it. So we have a new file just for the cart. And what do we need for that cart? Probably we will need same private method as in product test. So in product test we have, where is that, private create user and private user, so this, and probably refresh the database. So we copy it from here, that, we don't need test example, create user, okay. And what tests do we need, what cases? So for example, public function test button add to cart is shown. So what we will need, we will create a user, go to products page, no, actually create one product, create product, go to products page and assert C add to cart, right? Something like that. So let's create a test first and then we will create a feature. So create user is this, create user, let's let it be no admin, and then create a product. So product, actually factory product class create one product. We don't need more. Go to product page is response would be this, acting as this user, get products, and we assert C, response, assert C, add to cart. That would be the name of the button. Okay, let's clear it up a little. So no comments here, with faker is underlined, so it's not here. And also we need to import that user class from app user. And what do we do now? We run the test. Of course it will fail, but that's the whole point. PHPUnit, let's filter it and run only cart test. It should be one test, which should fail. So we should receive an F, failed to assert that contains add to cart. And this is exactly what we wanted. We want to see test failing, and then we implement the feature, and then the test turns into green. So that's the whole premise of test-driven development. Red, green, and then refactor if needed. So we go to our index blade, and we implement the feature now. Index blade for products. And let's add a button here. We will show TD to everyone now, not only admin. Probably add here, no, sorry, here, and here some tab, and then in that line we show route, for example, let's call it products, I don't know, products cart with product ID as a parameter, add to cart, And yeah, that's it. Probably there should be a button class, button small button, I don't know, primary, for example, add to cart. And let's run PHPUnit now, and let's see if it is green. And we see the failure here, but interesting part is that the failure is not in our latest test, but in something previous. So expected status code 200, but received 500. And I assume that the error is because homepage contains empty products, because in our code we've added a route which doesn't exist. And then it throws 500 error, and it doesn't return the page anymore. So we need to fix that, or either fix the test. So that's why I call it red-green refactor. So the test was red, we made the test into green, our own test, but broke something else. So we need to refactor either the test or the functionality. In our case, we need to add that route, and everything will be better. So in our web PHP, we add product cart to, for example, route get products cart product ID, for example, and cart. And now that route exists, and let's see if it turns our tests into green state. Yep, no F's anymore. So this way we've created, in TDD way, we've created a button add to cart, we've created a route, but first we've created a test which failed, and then we made it into green. So this is an example how to add some functionality with TDD, and I hope you understand the difference and some advantages of doing it test-driven way. And I recommend, there is another course called Test-Driven Laravel by Adam Wathan. It's really big, huge, 22 hours, but he creates the whole project with TDD approach. So first writing tests, then writing functionality, then adding more tests, more functionality, and go in full circle a few times to create the actually working real application. But for now, for this lesson, I've showed you a pretty simple concept of TDD.